Hello, my name is Mitchell Falco, and today I will be showcasing our work towards a domain-agnostic computable policy tool. Policies, or guidelines, such as this one, are often written in natural language. Sometimes, however, policies are not as straightforward. There can be ambiguity or variation in reader interpretations. The more complicated a policy becomes, the more likely that those two problems can occur. Computable policies, on the other hand, refer to encoding policies such that they are machine readable. Machine readable policies often introduce many benefits, such as automatic evaluation and querying. To ensure machine readability, frameworks are used, and those frameworks are often made with specific domains in mind. Examples being clinical practice guidelines with GEM and access control policies with XACML. Because those frameworks are domain specific, using them outside those domains often requires additional configuration, and that makes it difficult to reuse them. And then even then, the required changes can lead to more potential errors. And so one potential solution is to make use of the domain knowledge stored in knowledge graphs. This would preserve machine readability, mitigate inconsistencies, and also enable the use of domain knowledge within an evaluation. That last one is very important because most frameworks do not readily provide that capacity. Those that do lack tools to help work within them. Here's where ADAPT enters the fray. ADAPT is a domain-agnostic policy tool. It leverages the domain knowledge stored in knowledge graphs using W3C standards for ontologies and provenance, and then uses that knowledge to enable the construction and visualization of computable policies that include machine understandable domain knowledge. This approach can be used to reduce terminology inconsistencies and also augment the policy evaluation process. So before I show you a demo of what ADAPT can do, let's take a quick look back at that policy again, because that's the one we will be converting into a computable policy. So the American Diabetes Association advises all patients not to use cigarettes and other tobacco products or e-cigarettes. It gives an evidence rating of A, indicating that this guideline is supported by a lot of research. So, if we are going to turn this policy into a computable policy using ADAPT. So we go to ADAPT here. And now we go to the builder. And so here we have the builder UI for ADAPT. Right now we have a simple healthcare ontology loading into the knowledge store. You can see that based on these different attributes and fields, values we can select. And so for now, I'm just going to define the necessary policy information. We're going to call this recommendation 5.32 because that is the name of the recommendation. And we can even give a description if we want to. And so now we define the action or activity that this policy is addressing. In this case, smoking tobacco. I can also add the attribute and select type 1 diabetes to denote that we are addressing type 1 diabetes patients. We could also add a validity constraint, but that's not relevant for this policy. For conditions, this is where we put in the precedence. We define our precedence using evidence rating. So for that, we input the evidence rating A, And then for effect, this is where we input the response of the policy. And for that, we input not recommended. Once we're done, we click save, and we are brought here. This is the graph view of our policy. And as you can see, is encoded using OWL terms. The graph structure mimics Manchester syntax. And so the idea here is that it is able to be reasoned over using OWL reasoners like Hermit or other semantic reasoning processes. But this is not all. Adapt is capable of doing much more, and if you give me a moment, I will show you just what it is capable of doing. And so here we are back at Adapt. Nothing looks different, except what is this? Yes, now I have changed out the knowledge store in the back end to use the dynamic spectrum allocation knowledge graph and ontologies. So the way Adapt works is it will take any set of ontologies, hopefully, and it is loading them in and extracting attributes, and it is outputting the attribute structures that the user can then assign to the policy in a dynamic way. So that we have now demonstrated the how Adapt enables the creation of machine-readable policies across a wide array of domains, and leveraging and it leverages how it leverages the terminology within knowledge graphs. And I also have shown how policies are encoded in the OWL and PROV standards, which allow them to be used in reasoning processes to support domain practitioners in policy applicability and in evaluation. That is all, and I hope you enjoyed. Thank you.